Welcome to Terra Technica. In this video, we will explore the profound and sophisticated role that animals played in the Viking survival system. You will witness how the Norse mastered the ocean to hunt massive whales, the complex engineering required to bring these giants ashore, and the industrial-scale methods used to process and preserve their meat and oil. We will also take a deep dive into the world of Viking livestock, revealing how every animal, from the resilient shorthorn cattle to the dual-coated sheep, acted as a vital living machine within their society. This journey into the past will be a fascinating exploration of ancient ingenuity. I hope you have something warm and delicious to enjoy while you watch. My name is Mikhailo. I create these videos with a deep passion for the process, and your support is essential to help me improve the quality of our voiceovers, visuals, and overall content. Please consider subscribing to the project to join our community. Now, let's begin our journey. Enjoy the video.
The wind screams, not a simple rush of air, but a biting, metallic howl laced with salt and ice. You are pinned between the exposed granite of the settlement and the churning, dark water of the fjord. Every second is a calculation of energy expenditure versus necessity. This landscape, the North Atlantic edge of the world, demands total efficiency. It offers no quarter, only a constant gnawing threat of starvation and hypothermia. Survival here is not a passive act of endurance, it is an aggressive act of engineering. The people we call Vikings, farmers, traders, explorers, and raiders, did not survive this world by brute force alone. They did it by designing a living, breathing technological system, integrating the physiology of animals directly into their material culture, food matrix, and strategic logistics. They didn't just keep livestock, they maintained bioengineered resource generators capable of operating at peak efficiency under the most brutal environmental pressure the medieval world could offer. This was the core concept of the Norse survival machine, the seamless transformation of grass, brine, and meager root crops into stored energy, thermal defense, mobility, and structural material. It was a closed-loop system of input and output, where waste was redefined as precursor material for the next necessary product. To understand Viking success is to understand their radical integration of animal life, turning volatile biological processes into predictable, high-yield tools. The foundational block of this ecosystem was the hearth and the heat that radiated from it, the thermal core of the settlement. But heating the massive, drafty longhouses of the North Atlantic required more than just wood and turf. It required metabolic insulation. The animals were the first defense against the cold, acting not just as food storage, but as thermal batteries and dynamic heat exchangers placed strategically within the structural envelope of the home. Archaeological findings across Norway, Iceland, and Greenland demonstrate that animal housing, or the fjós, was often structurally linked or even directly integrated into the human dwelling. This was deliberate. The combined body heat of cattle and sheep, channeled through shared walls and ventilation systems, significantly reduced the fuel load required for human comfort during the savage winter months, a profound example of passive energy recovery. The central pillar of this agricultural engineering was the cattle. The Norse did not rely on the massive, slow-maturing breeds of continental Europe. Instead, they meticulously maintained and managed the specialized North Atlantic shorthorn, a resilient breed genetically optimized for sparse, poor-quality grazing and rapid maturation. This was an exercise in balancing size against efficiency. A massive animal requires massive input. The smaller shorthorns were lighter on the limited pasture land, yet still capable of converting highly fibrous material like collected seagrass or preserved hay into high-quality, high-fat milk. The priority for these cattle was not sheer muscle mass, but fat deposition. In a climate where caloric density was the difference between life and death, fat was the ultimate currency. Milk was the foundation of the Norse dietary structure, but it was too volatile to be stored in its raw form for long. This led to an elaborate bioprocessing industry centered around fermentation and preservation. The creation of skyr, a concentrated yogurt, and hard cheeses represented the maximum caloric extraction from the minimum biological input. The acidophilus bacteria used in fermentation acted as a primitive but highly effective preservation technology, breaking down lactose and concentrating protein, allowing the product to remain viable for months, even years, a crucial food source for the long ocean voyages that defined the Viking Age. Furthermore, the very intestines of the slaughtered animals, carefully cleaned and prepared, became the vessels for storing rendered fat and preserves, completing the internal resource loop. Nothing was wasted. Every biological structure was repurposed for human necessity. Complementing the cattle were the resilient Norse swine. While cattle demanded grazing land, pigs were the ultimate recyclers and converters of refuse. Historical ecology indicates that pigs were often free-ranging in forested areas or allowed to scavenge within the immediate settlement perimeter. Their specialized digestive system allowed them to thrive on foodstuffs the human body could not efficiently process, including kitchen scraps, dairy waste, whey, and root crops deemed too poor for human consumption. They were, functionally, the settlement's highly mobile waste management system. But their critical contribution was the speed of fat production. Pigs yield lard, a pure, stable form of stored energy, faster than any other domesticated animal of the time. Lard was used for cooking, soap making, and lubrication, making the swine population a rapidly deployable reservoir of necessary chemical compounds. The animal that defined Viking logistics and mobility, however, was the horse. The Norse horse, the direct ancestor of the modern Icelandic and fjord breeds, was not primarily engineered for heavy agricultural labor, which was often done by oxen or human power in specialized contexts. It was engineered for speed, endurance, and above all, efficiency across broken terrain. It was a compact, highly intelligent transport platform. The key to its utility lay in its unique gait, the tolt. This 4-beat lateral movement allowed the rider to maintain speed over uneven rocky ground without the jarring movement of a trot or the high energy cost of a gallop. This physiological adaptation was strategically utilized by the Norse to ensure rapid communication, transportation of critical supplies, especially iron ore, timber, and trade goods, and rapid deployment during raids or defensive maneuvers. The horse was the engine of terrestrial logistics, requiring minimal specialized feed while maintaining operational readiness. Evidence suggests that horses often traveled aboard the longships, requiring specialized stalls and loading systems, testifying to their critical role, not just in farm life, but in the projection of Norse power far beyond the coastal plains. They were integrated equipment, not merely beasts of burden. But the horse provided more than just mobility. Like all Norse animals, its utility was multifaceted. Horsehair, particularly from the tail and mane, was an extremely resilient fiber. It was braided into durable ropes, used for specialized fishing lines, and woven into materials requiring high stiffness and resilience, such as certain parts of sail rigging. The hides, once tanned, provided high-quality leather for saddles, harnesses, and crucially, specialized protective clothing, heavy, durable pieces that offered protection against the elements and occasionally weapons. The total integration of the horse into the infrastructure highlights the Viking mindset. Every living component had to pay its existential cost multiple times over. If cattle provided the caloric foundation and horses provided the mobility, then the sheep were the thermal defense system, the ultimate bioengineering feat in textiles. The sheep of the Norse world, specifically the ancestral Norwegian spell sow and the Icelandic sheep, were radically different from the fine wool merino favored elsewhere in Europe. They were engineered for the cold, wind, and damp of the Atlantic islands. Their wool was the primary thermal technology used by the Norse, transforming raw biological fiber into high-performance, water-resistant clothing and bedding. The secret was the dual coat structure. Unlike single-coated modern breeds, the Norse sheep possessed two distinct layers of wool. The outer layer, the tog, consisted of long, coarse, water-repellent guard hairs rich in lanolin. This layer acted as a tough, wind-breaking shell, shedding rain and snow. The inner layer, the thell, was a soft, fine, crimped layer that trapped air efficiently, providing superb insulation directly against the body. When these fibers were combined and woven into traditional Norse textiles like vadmal, the resulting material achieved a remarkable balance of warmth, breathability, and water resistance, a biosynthetic fabric superior to almost anything else available in the medieval North. The importance of vadmal cannot be overstated. It was not merely clothing, it was a standardized unit of economic exchange, functioning almost like a secondary currency in Iceland and parts of Greenland. Its value was standardized by quality and density, reflecting the meticulous control over the raw material and the processing labor required. This emphasis on quality control underscores the engineering approach. The textile was a product of high-precision biological management and skilled artisanal production. The sheep were, quite literally, factories producing financial wealth and life-saving technology. Furthermore, the processing of the wool involved specialized knowledge. The lanolin, the waxy substance naturally produced by the sheep's skin, was not discarded. It was a critical material, processed out of the wool, utilized for waterproofing leather, treating timber, and even as a base for rudimentary medicinal salves and lamps. The biological byproduct of thermal protection became an essential industrial lubricant and sealant, another testament to the closed-loop system management. The goat served a specialized parallel role alongside the sheep. Goats were far better than sheep at thriving on extremely marginal land, particularly scrubland and rocky coastal areas where grazing was scarce. They were the shock troops of the pastoral system, capable of converting the lowest quality vegetation into usable protein and materials. While their wool was less prized than the sheep's for thermal wear, goat hides were superior for certain types of specialized leather. Archaeological and textual evidence points toward the frequent use of goat skin for parchment, particularly in Iceland, where written records and sagas were preserved. The fine, durable nature of goat skin provided a stable substrate for recording the history and law that sustained the Norse communities. Moving beyond the domestic core, the Vikings integrated a variety of specialized animal units crucial for localized tasks and high-value trade. Fowl, primarily geese and ducks, were not simply kept for meat and eggs, though those were valuable supplements. Their ultimate biological engineering contribution was insulation technology, the down. Feathers and down formed the core of Norse bedding systems. In a climate where sleeping directly on cold stone or earth was fatal, the feather bed was a vital survival tool. Down, harvested carefully to avoid stressing the birds, provided an ultra-lightweight, extremely efficient thermal buffer. This technology, perfected over centuries, ensured that essential core warmth was maintained during the long, dark winters. The dog, often a robust Spitz type, the ancestor of breeds like the Norwegian elkhound or the Icelandic sheepdog, was perhaps the most ancient form of biological collaboration. The Norse dog was a multi-role unit: herd management, hunting partner, and vital psychological companion. Their keen senses provided an early warning system against both human and predatory incursions. Moreover, in the integrated settlement system, dogs often played a hygienic role, consuming scraps and refuse that might otherwise attract pests or foster disease. This biological partnership helped maintain the equilibrium of the tightly packed longhouse environment. The Norse economy also relied heavily on high-value wild harvested animal products, demonstrating their capacity to manage and integrate non-domesticated biomass into their survival system. The search for luxury furs, fox, marten, squirrel, and otter, drove extensive trapping and trading networks across Scandinavia and Russia. These furs served two purposes: providing ultra-luxury thermal clothing for the elite and, more importantly, acting as the foundation of international commerce, allowing the Norse to acquire silver, wine, and specialized tools unavailable in the North. The entire value chain of the fur trade hinged upon the systematic knowledge of animal migratory patterns and processing techniques. Perhaps the most radical element of the Norse bioengineering system was the managed exploitation of marine megafauna, the seals and the whales. Survival in Greenland, Iceland, and the northern reaches of Norway was impossible without tapping into the massive caloric and material wealth of the ocean. Seals were a predictable, localized resource. The annual seal hunt was a carefully timed operation, integrated into the ritual and economic calendar. Every part of the seal was critical. The meat provided essential winter protein. The hides, thick and water-resistant, were used for specialized clothing, especially trousers and outer garments used for sea travel. They were inherently lighter and more flexible when wet than tanned cowhide. However, the seal's most critical contribution was its blubber. Blubber is dense, pure fat, far exceeding the yield of any terrestrial animal. It was rendered down into oil, which served as the primary fuel source for light and heat across the North Atlantic settlements, particularly in treeless Iceland and Greenland. This seal oil was also used as a preservative, coating wooden structures and rope, reducing rot and degradation. In the deepest settlements, the existence of artificial light, allowing work to continue through the 6-month darkness, was solely dependent on this biological energy source. The seal was therefore the oil well of the Norse world. Whaling, primarily conducted through strandings or localized opportunistic hunts near the shore, represented the apex of large-scale bioresource acquisition. When a whale beached, the entire community mobilized in a highly efficient processing operation. A single whale yielded staggering quantities of material, tons of meat, blubber for illumination and waterproofing, and bone. Whalebone was treated as a structural material, an organic substitute for scarce timber. It was used to fashion tools, sled runners, house components, and even specialized items like the decorative plaques found in high-status burials. The strategic use of whalebone in treeless areas showcases the Vikings' genius for adapting available biological resources to solve intractable engineering problems. The systematic control and maintenance of all these biological systems, from the tiny spale sow sheep to the massive stranded whale, required profound traditional ecological knowledge, codified into law and social practice. The laws codified in the Icelandic Grágás, gray goose laws, for example, dedicate extensive sections to animal ownership, grazing rights, branding, and resource management. These laws were, in essence, the operational manual for the bioengineered system, dictating how resources must be shared, protected, and utilized sustainably to prevent the collapse of the fragile ecosystem. In the Norse view, the life cycle of the animal was inherently linked to the life cycle of human material culture. Consider the specialized construction materials used in their most famous achievement, the longship. The ship was an intricate weave of wood, iron, and animal products. The sails were often made of coarse woolen vodmal, treated with animal fat or oils to enhance weather resistance. The ropes, while sometimes plant-based, frequently incorporated horsehair or leather straps for critical structural points. The caulking, the seal between the planks, relied on animal-derived pitch or fatty materials mixed with wool fibers, turning the ship itself into a biologically insulated, waterproof vessel. The very mobility and exploratory range of the Viking Age was underpinned by applied zoology. Even the spiritual and social identity of the Norse was interwoven with animal engineering. The display of animal skulls, bones, and furs within the longhouse signaled status, successful hunting, and resource security. The ritualized slaughter, or blot, was often centered around animals, not just as sacrifice, but as a deliberate act of resource centralization and consumption, ensuring that the necessary fats and proteins were consumed communally during critical times of the year, particularly midwinter. The animal was simultaneously utility, wealth, and spiritual conduit. The integration extended deep into metallurgical practices. Iron smelting was a crucial industry, yet it required intense heat and sustained fuel. While charcoal was the primary source, animal waste, particularly bone and horn, provided critical additives. Bone ash, for instance, was used in some refining processes. Tallow and animal oils were indispensable for quenching and tempering iron tools and weapons, fundamentally altering the material properties of the metal. The high-performance steel of a Viking axe relied in part on the biochemical contribution of the farmstead. The greatest challenge facing the Norse engineers was sustainability, particularly in new, volatile territories like Greenland. Initial success was often driven by a surplus of local wild animals, caribou, seals, and Arctic fowl. However, the subsequent introduction of domestic animals created immediate pressure on the delicate Arctic grass and shrublands. The Norse adaptation involved a constant, localized rotation system. They did not practice monoculture. They practiced biological diversification, maintaining a heterogeneous mix of cattle, sheep, goats, and horses to ensure that varying grazing habits exploited the landscape without denuding it entirely. The system was designed to bend, not break, under environmental stress. In Greenland, where the climate eventually tightened its grip, the survival system reached its limits, demonstrating the fragility of even the most sophisticated bioengineering when faced with overwhelming climatic shift. Analysis of midden heaps, domestic waste piles, in the Greenlandic settlements shows a dramatic shift over time. Initially rich in domestic animal bones, the later layers show an increasing reliance on seal and marine resources. This indicates that as pastures failed, the settlers desperately shifted their entire biological engine toward the ocean, utilizing their marine resources to substitute for the lost terrestrial productivity. They were attempting to re-engineer their survival system on the fly, substituting the shorthorn cow with the harp seal as the caloric cornerstone. In the end, the Norse survival system was a masterwork of applied biological science that predated modern engineering by a millennium. It was a recognition that to conquer an environment defined by scarcity and cold, you had to turn living organisms into high-efficiency machines. They managed genetic lines for thermal properties, deployed specialized animals for specific ecological niches, and engineered sophisticated industrial processes around animal byproducts. The Viking Age was not simply a story of exploration and warfare. It was a profound, successful experiment in sustainable biological integration, where the animal was not merely a companion or food source, but an essential, engineered component of human persistence against the absolute edge of the habitable world.